Right now, there are thousands of developers sitting at their desks.
Oh, easily.
Yes, staring at their screens. And they are completely locked out of their own cloud storage buckets.
Which is an incredibly frustrating feeling.
It really is. And the crazy thing is, it's not because they've been hacked and, it's not because their billing failed.
Right.
They're locked out because their own automation tools are, well, politely trying to hand the server an ID card that officially died yesterday.
That's a great way to put it.
Welcome to the Deep Dive. We are thrilled to have you with us today because we're unpacking the hidden hurdles of modern computing.
Things that happen behind the scenes.
Exactly.
Yeah.
We were looking at why your tech feels like it's breaking and why that might actually be a really good thing.
It is a moment of massive transition in the industry right now.
It really is.
We are pulling our insights today from Aaron Rose's writing over at the tech-reader blog, specifically looking at the landscape around June of 2026. And the through line in his analysis is just fascinating. We're going to start high up in the cloud, dissecting a notoriously confusing Amazon Web Services error.
Which I know has caused a lot of headaches.
Oh, massive headaches. And then we're going down to the edge.
Right, looking at the physical minimalist hardware on your desk to see how cutting the bloat is entirely changing what we can accomplish locally.
So to start with the cloud.
Yeah, specifically Amazon S3. Because there is a serious clash happening right now between entrenched development habits and, well, new non-negotiable security standards.
Absolutely.
Okay, let's unpack this. Aaron Rose highlights this incredibly frustrating S3 error. Access control list not supported.
Yes, that dreaded red text.
Right. You get this giant red flag when you are simply trying to upload a file, and your brain immediately thinks, oh, I don't have the proper administrative permissions to do this.
Which is the logical assumption.
Yeah, it's like walking into a sleek, modern streaming service headquarters and trying to swipe an old Blockbuster video rental card to get into the building.
I love that. It's a perfect analogy because the system isn't rejecting your identity, right?
Right.
It's rejecting the fundamental mechanism you're trying to use to gain entry. Let's look at the technical reality behind this.
Let's do it.
For years, the way you told S3 who could see your files was by using an access control list or, an ACL.
Oh.
This is resource-based security. You were essentially stapling a tiny permission slip directly to every single file or bucket, saying, this specific user can read this specific object.
Which sounds fine on a small scale, but I mean, if you have 10 million photos in a bucket.
Yeah, managing 10 million individual permission slips sounds like a logistical nightmare.
It is an absolute nightmare. It's difficult to audit, and frankly, it leads to massive security leaks.
Right.
That's why modern cloud architecture has largely abandoned resource-based ACLs in favor of identity-based security.
Namely, IAM policies and bucket policies.
Exactly. Now, instead of checking a slip stapled to the file, AWS checks a master registry to see what your identity is actually allowed to do.
Makes sense.
And many organizations now configure their S3 buckets to disable those old ACLs completely by default.
Wait, but if AWS knows this mechanism is dead, why does it throw a permission error that sends developers on a wild goose chase through their IAM role settings?
Yeah, it's confusing.
If my IAM policy says I have full access to the bucket, why does the upload still fail?
If we connect this to the bigger picture, the error starts to make logical sense. The issue isn't your actual IAM permission.
Okay.
The issue is the invisible baggage your deployment tools are carrying. Think about how many third-party backup software tools, deployment pipelines, and legacy scripts were built over the last decade.
Oh, thousands. Millions, probably.
Exactly. It was standard practice for those tools to automatically inject ACL settings during an upload.
Because that was the official way to do it for over a decade.
Precisely. A deployment tool might quietly add a parameter like --ACL public read in the background of your upload command.
Oh, I see.
The developer might not even realize their software is appending that flag. But when that legacy command hits a modern bucket where ACLs are turned off, the bucket actively rejects the request.
Right.
It's saying, look, we see you trying to set an ACL, and we don't accept those anymore.
So the system is forcing a structural shift. It's not a bug. It's AWS aggressively dropping outdated features to enforce a more streamlined, centralized, policy-driven architecture.
That's the real listener takeaway here. The transition from resource-based to identity-based security requires a change in troubleshooting.
Yeah, the fix isn't to spend 3 hours adding more administrative privileges to your IAM role.
Not at all. You need to open the S3 console, navigate to the bucket, and check the object ownership setting.
Right. Aaron's breakdown points out that if this is set to bucket owner enforced, the bucket has disabled ACLs entirely.
Which means the fastest fix is simply subtraction. You go into your deployment scripts, find wherever it's trying to pass that legacy ACL parameter, and delete it.
Just rip it out.
Yeah. Once you stop trying to hand the server a blockbuster card, the upload succeeds natively based on your IAM identity.
Exactly. Less bloat, tighter control.
And what's really striking is that this less is more philosophy isn't isolated to massive cloud data centers.
No, not at all.
We are seeing the exact same drive to hoard compute cycles and eliminate legacy overhead right on our desks at the hardware level.
You're talking about edge computing,
Yes.
and specifically the minimalist operating systems running on devices like the Raspberry Pi.
Yes, the great minimal OS showdown. Aaron Rose's blog dives into the performance battle between two operating systems built for the Edge Diet Pi and Raspberry Pi OS Lite.
Right.
Think about it like moving into an apartment.
Okay, I'll look where this is going.
If you flash your device with Raspberry Pi OS Lite, it's like moving into a place that's semi-furnished. The landlord left a couch, a microwave, maybe a decent TV.
It's comfortable?
Yeah, it feels like the familiar Debian Linux environment, and you've got standard network management tools right out of the box. But if you choose Diet Pi, you are moving into an apartment with bare concrete floors and exposed pipes. You have to meticulously construct every single piece of furniture yourself.
What's fascinating here is what we can call the minimalist's dilemma.
Okay.
When you are building a server for a specific resource-intensive task on constrained hardware, say a Raspberry Pi 3B Plus with really limited memory, every single megabyte of RAM matters.
Oh, absolutely.
Every CPU cycle wasted on a background task is a problem. While both of these systems boot straight to the command line, skipping the graphical desktop entirely.
Right, no heavy graphical interface.
Exactly. Diet Pi goes much further into the architecture of the system to optimize.
Wait, how far are we talking? What does bare concrete actually look like at the operating system level?
It looks like ruthlessly culling background demons.
Wow.
A standard OS runs dozens of services in the background just in case you need them.
Yeah.
Bluetooth polling, printer schoolers, extensive logging. Diet Pi kills almost all of it.
That is aggressive.
It is. Furthermore, it utilizes logging to RAM rather than the physical SD card.
Oh, that's clever.
Yeah.
Because constantly writing log files to a cheap micro SD card is a massive bottleneck.
Huge bottleneck.
It slows down input-output speeds and degrades the physical flash memory over time.
Precisely. By writing those logs to volatile RAM, Diet Pi drastically reduces I/O operations, which extends the life of your hardware and frees up the processor from waiting on slow disk writes.
That makes so much sense.
It forces you to intentionally add back only the specific software packages your project actually needs. It's an architecture of ultimate localized control.
But the reason this level optimization matters isn't just about saving space for the sake of it, right?
No, not at all.
It's about hoarding those CPU cycles because of what we are now demanding these edge devices do. Hobbyists aren't just using these tiny boards as simple file servers anymore.
Right, the game has changed.
They are trying to squeeze compute-heavy tasks onto them, and the ultimate stress test for that hardware.
Well, it's local artificial intelligence. It is the final frontier for edge computing right now.
Here's where it gets really interesting. I'm having a hard time picturing this. You're talking about running AI on a credit card-sized board powered by a phone charger,
Yes.
while companies like OpenAI are building literal nuclear-powered data centers to handle their models. What trick is the Raspberry Pi using to bridge that massive hardware gap?
To understand the trick, we have to look at the hardware specs of the newer Raspberry Pi 5.
Okay.
Specifically, the 8GB model Aaron Rose tests in his analysis. You're right that training a massive foundational model from scratch requires a data center.
Right.
But we are talking about inferencing at the edge, running a pre-trained model locally to generate text or recognize an image.
Oh, inferencing, right.
The Pi 5 utilizes a quad-core Cortex A76 processor at 2.4 gigahertz, which is powerful. But the real secret weapon is the 8 gigabytes of LPDDR4X RAM.
Wait, so it all comes down to the memory. Why does the RAM type matter so much more than just a fast processor?
Because AI inferencing isn't just a math problem.
Okay.
It's a massive data shuffling operation. To generate a single word, the processor has to load the neural network's weights from memory, run the calculation, and output the result.
Right.
If the memory is slow, the processor just sits there, idle, waiting for the data to arrive.
Yeah.
The LPDDR4X RAM on the Pi 5 provides incredibly high memory bandwidth, allowing the system to feed data to the processor fast enough to make local AI feasible.
But even with fast RAM, 8 gigabytes is tiny.
It is.
Most modern language models are tens of gigabytes in size. How do you fit a massive neural network into an 8 gigabyte box?
Through a process called quantization.
Quantization.
Think of an AI model's parameters like incredibly high-resolution TIFF images. They are highly precise, but take up a massive amount of space.
Okay, I'm with you.
Quantization is the mathematical equivalent of converting those TIFFs into smaller JPEG files.
Oh, wow.
You compress the precision of the numbers, say, dropping from a 16-bit floating point number down to a 4-bit integer. The model loses a tiny fraction of its nuance, but the file size shrinks dramatically.
Which allows a capable, intelligent model to actually fit entirely within that 8 gigabytes of RAM.
Exactly.
So we're essentially lowering the resolution of the AI's memory. It's slightly less precise, but radically smaller and faster to process.
This raises an important question, however, about realistic deployment decisions.
Right.
Because while quantization and memory bandwidth are incredible workarounds, the Pi 5 still lacks a dedicated neural processing unit, or NPU.
So it's doing all the heavy lifting with its general-purpose CPU muscles, rather than having dedicated silicon built specifically for AI math.
Right. It's a powerhouse, but it has hard limits. It can run a quantized, lightweight language model, or handle local voice recognition and object detection on a camera feed.
Which is still impressive.
Very impressive. But if you try to deploy a massive, complex, deep learning model, it will bottleneck. The CPU simply can't process the floating point math fast enough without an NPU. You have to tailor your expectations to the architecture.
Okay, so let's synthesize this. You've navigated the S3 cloud security protocols. You've flashed a ruthlessly optimized, bloat-free Diet Pi operating system onto your capable Raspberry Pi 5.
Right.
You've quantized a lightweight AI model to do object detection locally on your home network. And because you are hoarding every ounce of computing power, this Pi 5 is sitting in a closet with no monitor or keyboard attached.
Right. Headless setup.
How do you actually interact with it?
You need a remote desktop protocol. You need a way to see the screen without plugging one in.
Which brings us to the final piece of the tech stack. The tech reader analysis details the current transition in remote management Raspberry Pi Connect versus real VNC.
Yes.
And to me, this perfectly mirrors the shift we saw with AWS.
It really does.
Real VNC is like a clunky third-party universal remote. It works, but you have to download external software, create a separate account, configure your router to pass the traffic, and, hope it plays nice with your system.
Yeah, it's a lot of friction.
Raspberry Pi Connect, on the other hand, is like a sleek, native smart app built right into your brand new television by the manufacturer.
It is an industry-wide consolidation toward native control.
Yeah.
For years, real VNC was the standard.
Right.
But as the Raspberry Pi OS evolved, specifically moving to the newer Wayland display server architecture in OS 12, older, third-party tools that relied on the legacy X11 Windows system started to break or require complex workarounds.
The ground shifted under our feet again, the underlying architecture changed, breaking the old tools.
Precisely. Raspberry Pi Connect is the native response to that shift. It's a new service integrated directly into Raspberry Pi OS.
Oh, nice.
And rather than relying on legacy routing, it uses WebRTC, the exact same peer-to-peer technology that powers a Zoom video call, to securely stream your Pi's desktop directly into a standard web browser anywhere in the world.
That is so much cleaner. No complex router configurations, no third-party software overhead.
However, there's a hardware limitation to this new native approach, isn't there?
There is. Connect is currently in beta and is totally free, but because it relies on that newer architecture and requires hardware-accelerated video encoding to stream the desktop smoothly, it strictly requires a Raspberry Pi 4, a Pi 400, or the new Pi 5.
Right. It will not work on older models.
It's looking forward, not backward.
Yeah.
And think about how beautifully this connects our entire journey today.
Yeah.
With Amazon S3, AWS realized that relying on scattered third-party ACL scripts was a security liability, so they force users toward native, centrally managed bucket policies.
Exactly.
Now, at the edge, the exact same consolidation is happening. The hardware ecosystem is moving away from fragmented legacy third-party software like real VNC, providing a seamless, natively integrated experience out of the box with Pi Connect.
The tolerance for legacy bloat is just vanishing across the entire spectrum of technology.
So what does this all mean? If we step back and look at the landscape, the tech industry is marching in one definitive direction.
It really is.
Whether you are Amazon operating the largest cloud infrastructure on Earth, or you are a hobbyist building an AI server in your living room, the mandate is clear to possess the invisible baggage.
Out with the old fragmented tools.
In with native, highly optimized, policy-driven control, we are moving towards systems that are leaner, faster, and far more rigid in how they enforce their own architecture.
And that rigidity is exactly why so many people are hating that invisible wall you mentioned at the beginning of our deep dive.
Yes.
When your tools break, it usually isn't a glitch. It is the system politely refusing to accept an outdated methodology.
The wall is the new architecture working exactly as intended.
Which leaves us with a truly fascinating implication for the near future.
Ooh.
We've seen how enterprise environments like AWS strictly enforce identity-based policy over legacy access.
Right.
We've also seen how localized edge devices like the Pi 5 are becoming powerful enough to run localized autonomous AI. If we project this trend forward, well, as our personal localized tech becomes more capable, are we moving toward a future where our home networks will need to be as strictly governed as an enterprise cloud environment?
That is a staggering thought. If my smart home is running a quantized AI model locally to anticipate my needs, does my refrigerator suddenly need its own IAM policy to communicate with my thermostat safely?
Exactly. When the power of the cloud moves to the edge, the security protocols must follow. Will managing your home network eventually require the same architectural rigor as managing an Amazon data center?
The walls are moving from the server farm right into our living rooms.
They absolutely are.
We want to thank you so much for joining us on this deep dive today. We hope we've helped translate some of that frustrating error text into something that actually illuminates the mechanics of where technology is heading.
It's been a great discussion.
Keep that final thought in mind the next time you're deploying a new piece of hardware on your network. Until next time, keep exploring, keep questioning, and remember, when you hit a wall, you don't necessarily need a heavier hammer. You just need to realize they changed the locks. Take care.